we're continuing our discussion on proportions, rates, ratios, proportions. And so looking at this first question that you have on Go Formative, there's this beaded necklace, right? And on this beaded necklace, there are 5 beads for like one thing. For one portion, 5 beads. And there's 2 reds and 3 blues. They are telling us that each one of these sets is 1.25 inches. And that the whole thing is going to be 20 inches. So who can tell me how to figure out how many of these clusters I would need? Now I'm going to ask everybody to have your videos on the whole lesson, because that's how I'm going to get feedback from you. So everybody videos on whole lesson, just so I can see.
Wait, so do we follow along on Go Formative
Yep,
and paper notes?
You might not need the paper notes because the Go Formative will keep it, but if you'd like paper notes as well, that's great. But what I want to know now is, how do I know how many of these clusters of 5 I need for this necklace? Who can tell me? How can I tell how many of these clusters of 5 I would need?
You can divide 20 by 1.25 and you get 16, so we're going to need 16 clusters of 5 beads.
Okay, so I need 20 inches total. If I divide that by my 1.5 inch segments,
it's 1.25.
1.25. I get 16 of those segments, 16 of these things right here. So if my ratio of red to blue is 2 to 3, I need that ratio 16 times. So I can simply multiply both my numerator and denominator of my ratio by 16. And that would give me my 32 48ths, or 32 reds to 48 blues, correct? Which looks like the first selection. Now here's one thing that's really cool I want to show you. And this is going to be something kind of new, but it's going to be applicable later. So if I have my ratio 2 to 3, what's another, so this 32 to 48 is an equivalent ratio. Who can give me another ratio that is equivalent to 2/3? I just want one more that's equivalent.
4, 6.
4, 6. Okay? And I'm about to show you a really cool property of proportions. When something's proportional, the cross products of your ratios are always equal. So I think we're all on the same base. Okay, and Max says 6 to 9. Let's do that one too. What I'm saying is, if I multiply these two values together, if it is proportional, it'll always equal these two values. So let's test it out. 4 times 3 is 12. 6 times 2 is 12. All I want you to worry about right now is big idea. It's true. So let's try it with the 4 6 and the 6 9s. 4 times 9 is 36. 6 times 6 is 36. It's always true for equivalent ratios, and equivalent ratios form what we call proportion. So I just want it stashed upstairs right now that it's true and it works. Okay, it's true and it works. That's all I need you to know right now. Problems like problem 5 before, and I just know from teaching pre-algebra before and talking with your teachers that on problem 5 we have a variety of ways to solve that. Who can tell me one way they would go about getting an answer for x on problem 5? What's one way they would do? Thinking back to last year, problem solving, number fluency. What's a way that you might go about doing number 5?
So like you showed the proportion thing where you can multiply.
Yeah, so that's kind of like the thing I'm showing you now. I'm kind of looking for another way you may have done it. Thinking back to your like constant proportionality work you did last year. What's another way you might have done it? Not looking at cross products right now.
You can multiply 7 by 5 and 5 by 7.
Okay, so you're saying like get denominators of 35? Okay, cool. And so what do I do? What do you want me to do with this though? I got 7 35ths.
Well,
or this one you want it as a 28?
Yeah.
Okay, 28 35ths. And then you're saying to get this to be 7, I'm dividing by 5? So 28 divided by 5, is that what you're telling me to do? Yeah, that's cool. I like that. So you're saying 4/5 is 28 35ths. Well, if I want my 35ths to be a 7, I'd have to divide by 5. And that gives me 5.6. I like it. I know I've seen a lot of you do that already this year, similar things. I've also seen something like to get from 5 to 7, they do 7 divided by 5 to get a multiplier of 1.4, and they multiply both things by 1.4. Can I get a thumbs up if that's something that you've done before? Okay, cool. And those are great ways. They're excellent ways, and I want you to continue to use those ways, actually. But as I was alluding to with our proportions, I'm going to prove to you that this cross product thing works as well. So if I'm doing cross products, I'm looking at 5 times x, which is 5x, and I'm looking at 7 times 4, which is 28. And when I show that my cross products are equal, just like if 1/2 equals 2/4, right? I get a 4 equals 4. Same idea. I can solve for x here. And from that, I can get my the same 5.6. You guys all recognize that's the same answer? It's pretty cool. Now, I would probably use cross products in this, but all those methods are great for an example like this. All right, but we're actually going to jump down to something that it wouldn't be great to use one of those other methods. This is why I'm giving you another tool for the tool belt. We're going to actually jump down together. Oops. Jump down together. Oh, Jack has a question. The 28 over 5. Okay, that was from number 5, Jack. So Jack, what he did was got a common denominator here of 35. And to get from 5 to 35 times 7. So these two are equivalent there. And then what Sam was saying is, well, that needs to be equivalent to something with 7 in the denominator, which would be that divide by 5 situation. Really, all these methods are kind of the same thing. They're just shown in a little different way. Thanks for asking for a clarifying question. So you're going to notice this problem right here, number 8. So you can use one of those methods. It just becomes increasingly difficult. Are you seeing how that would be kind of tricky? To get 30 as your denominator and then get your two things to equal. Here is a situation where you want that tool in your tool belt for cross products. All right? So stay with me. And Oliver, I saw you had a question too. We'll get to it after this. So just like 1/2 equals 3/6, and I get a 6 equals 6 from my cross product. Same idea. No different idea. My cross products for this problem would be something like 10n plus 20. That's if I do my 2n plus 4 5 times. And a 6n. So I'm going to hold up here 1 second. Does everybody see where I got these values from my cross products? Right? I just multiplied the same way I did 1/2 equals 3/6 to get 6 equals 6. I multiplied my cross products. I got a 10n plus 20. It's important that you distribute here, right? That's grouping. So 10n plus 20 equals 6n. Do I get thumbs up? I'm looking for thumbs up everywhere. Got the thumbs up going? Nate, you're not going to, you do? Okay. So from here, we've done it a million times this year. This is just an equation to solve now. So what I would do is get a variable on one side next. And that would give me 20 equals negative 4n. And I would divide both sides by negative 4 to isolate a variable n of a value of negative 5. And you can always check your answer. You can plug this in for n, get negative 5 over 5. Plug it in for n, get negative 6 over 6. And those are equivalent. Who had the question? So we're going to practice this cross product method here. I'm going to ask Leah to unmute and tell me what to do here.
So first you cross multiply, so you get 9 is equal to 5y.
Okay.
And then you divide both sides by 5 and you get y equals 9/5.
Yeah, 9/5. Or you could do 1 point, that's 1.8. I would take either one of those. Yep. I'm a fraction fan though, you know me. All right, let's look at number 7 real quick together too. Thank you, Leah. We're going to do cross products. I get a 3b and a 65. So b would be something like 21 2/3, 21.6 repeated. And again, this is really efficient, almost needed when we have those variables on both sides, or we have two terms in a numerator or denominator. Something like this, I suggest to use your discretion, whatever you're most comfortable with. But if we get to something like what number was that? Something like number 8, those cross products are going to be key. All right. One more thing I want to show you with some proportion work is number 9. And maybe you've heard me say it once or twice, but math is communication, and it's important that we stay organized. So let me show you the number 1 problem. So I'm going to do number 9 wrong, and I'm going to call on somebody to tell me. I'm going to call on a random person, so it could be you. Look out. I'm going to do problem number 9 wrong on purpose, and I want you to tell me what I did wrong, okay? Because this happens. I see it in kids' work all the time. So, an 8-ounce can of orange juice contains 97 milligrams of vitamin C. So I know there's a ratio, 8 to 97, okay? 8 ounces to 97 milligrams. How many milligrams are there if I have 12 ounces? So there's a proportion. I did something wrong. And I would like Miles to try to tell me, what did I do wrong?
Is the X and the 12 flipped on the wrong? Is it opposite?
Well, let's see. What would be an easy way to tell if it's right or wrong with where my X and my 12 are?
The 12 is the ounces, so the ounces should be on the top since it's on the top on the other side.
Good point, Miles. Let's check this out. So let's say I used units. I've got ounces and milligrams. If I put those units on there, Miles, was that easier or harder to tell what I did wrong?
Easier?
Way easier, right? Do you see how using the units keep you on track? So, yes, if I were to do this correctly, I would get organized. 8 ounces is to 97 milligrams, as 12 ounces is to unknown milligrams, right? Do you see how ounces to milligrams has to be ounces to milligrams to make a proportion? And your units will save you, trust me. Okay? Now, there's a couple ways to solve this. We could definitely do cross products, which would give us an 8x equals, what's 97 times 12? 1,164. Okay? But I'll let you know, this is probably not the way I would solve it. Here's why. I know that 8 times 1.5 is 12, so I probably would just multiply by 1.5 there. I just want to show you, though, like, do you see how I have that flexibility to choose ways? Can I get a head nod? Do you see how I have that option and flexibility? The only reason I have that option and flexibility is because I have the knowledge, right? So use your knowledge to find a way that works best depending on situation. Like the cross products will always work, but right here I thought it was just easier to multiply by 1.5.
Also, Mr. McKenzie, you can use the process of elimination for the answer key because all the other answers are under 97 milligrams.
I like that. So it has to be more, right? If you have more juice, you have to have more milligrams of vitamin C. Yeah, I like that. So that has to be. That's good test-taking strategy. So that's everything we need to know for today, friends. You're going to get working on that co-formative. You're going to use the chat with me if you want to look at anything together. And you're going to continue to grow your brains.